All right, everyone. Today we are going to talk about something amazing that happens all around you, even though you can't see it. Imagine you are standing outside on a sunny day and you feel warm on your skin. But the air might still feel cool. That heat you feel is actually coming straight from the sun through something called radiation. Radiation is different from heat moving in the air or through materials. It doesn't need air. It doesn't need metal or walls to travel. It can go straight through empty space. That's how heat from the sun reaches us, through the cold, empty space between the Earth and the sun. And that's what we're going to understand today: how radiation works. Let's start with something simple. Every object, as long as it's not frozen at absolute zero, sends out little packets of energy called radiation. Your desk, your chair, your skin, even ice, they all send out radiation. The hotter something gets, the more energy it shoots out. Scientists a long time ago realized that if we heat something enough, like a stove, it starts to glow red. Heat becomes visible. That's called thermal radiation, the kind of radiation that comes from temperature. Now, radiation is actually part of a big family called electromagnetic waves. This family has members you know, like visible light, ultraviolet light, X-rays, microwaves, and radio waves. When we talk about heat transfer, we care about a special part of this family, thermal radiation, which includes light and especially infrared waves. Most things around you are giving off infrared radiation because they're not hot enough to glow like the sun. To help us understand how good something is at sending out radiation, scientists use a pretend perfect object called a blackbody. A blackbody is a champion emitter. It sends out the maximum possible radiation for its temperature. So we compare everything else to this perfect blackbody. Hotter objects send out more radiation, and colder objects send out less. This follows a simple rule called the Stefan-Boltzmann law, which says the heat coming out goes up super fast with temperature. If you make something twice as hot, it doesn't send out twice the radiation, it sends out 16 times more. But it's not just how much radiation comes out, but also what color or wavelength it has. There's another rule called Wien's law that says hotter objects send out shorter wavelength radiation. That's why the sun looks bright and gives off light you can see, while a hot stove only glows dull red. Really cold things, like ice, mostly send out radiation you can't see, infrared. We also talk about surfaces. Some surfaces are really good at sending out radiation, like black surfaces, while shiny mirrors are terrible. They reflect most of it. This is called emissivity. Emissivity is a score between 0 and 1. Black bodies have 1, shiny mirrors have close to 0. Radiation also travels in all directions, like the way light from a lamp spreads everywhere in a room. Sometimes, engineers need to know how much radiation is going in a certain direction, so they use something called radiation intensity, which is like measuring how bright something is from a certain angle. Another interesting point is when radiation hits a surface, 3 things can happen. It can be absorbed, like sunlight making you warm. It can be reflected, like sunlight bouncing off a shiny car. Or it can go through, like sunlight passing through glass. We use big words like absorptivity, reflectivity, and transmissivity to talk about how much energy is absorbed, reflected, or transmitted. Now here's something cool. Sometimes you have radiation going back and forth between surfaces. For example, inside a greenhouse, sunlight comes in easily, but heat gets trapped inside because the glass doesn't let infrared radiation out easily. This is called the greenhouse effect, and is why greenhouses stay warm even when it's cold outside. Radiation is also why satellites and spacecraft cool down or heat up in space. There's no air out there, so the only way they lose heat is by radiation. Engineers have to design them really carefully to balance the radiation they send out and the radiation they receive from the sun. So next time you feel the heat of the sun on your skin or notice a hot stove glowing, remember it's all about radiation. Energy flying through space without needing air or touch. And now you know the simple secrets behind it, just like an engineer would.